Hi, I'm Yen-Chia. Can people stay back, hear my voice? Is that okay? Okay. I'm from the Robotics Institute in Carnegie Mellon, and today I'm going to present Smell Pittsburgh. It's a mobile application for reporting and tracking pollution orders. You can download the app and also access our data and also the visualization on smellpgh.org. And during the presentation, I'm going to explain the motivations first, and I'm going to show you a demo, and then present 3 studies, and then give some takeaway messages. So just some, it's okay. So just some brief background about Pittsburgh. The American Lung Association has listed Pittsburgh in the top 10 most polluted cities in the United States by year-round particle pollution. And currently, the health department, they deploy a lot of sensors in the cities. And these sensors, they measure air pollutants. But although they tell the concentration of these pollutants, they did not tell how the communities are affected by these pollutions. So we hope when we build this system, we can empower communities to contribute all these other experiences. Because when we talk to them and they design a system with them, they often describe that in the morning, they will smell some sulfur things like really strong sulfur smell. And we hope that by using this app, we can address air quality issues collaboratively. This is the current approach about how the health department collects data. Right now, they use text boxes to collect like time, location, and the description of the smell. But the problem is, using this way to collect data may suffer from data quality issues, and also the process is not transparent. When we ask users to submit all this information retrospective, it is likely that there will be errors in the data, and then when we are conducting the analysis, there will be problems. Also, when people report smell, it's like going into somewhere that we don't really know what happened, and it's really hard to know if that problem is on a local scale or a citywide scale if we didn't visualize all the data. So here I'm going to present a demo. Users can select different ratings of the system from 1 to 5. And then they can specify the pollution source, like industrial or wood smoke or rotten eggs. And then they can also specify the symptoms like headache, sore throat. And then the report will be submitted to the health department. Users can also use the setting panel to provide a contact information to the health department. And then they can also choose which type of notifications that they want to get, like when air quality index rises. This is the visualization. Users can pan and zoom on the map. All these triangular icons indicate smell reports, and the color indicates the smell rating. So you can click on the icon and then see its content. The circle icons indicate particulate matter sensor readings. Now we are going to animate this. So watch out the right sensor. When that sensor becomes red and the wind blows to our north, which is the blue arrow, and we will see a lot of smell shows up at the smell report. So in this way, we can show the trends in the day. Now I'm going to talk about 3 studies. The first study is a system usage study. So we study the data for about like 23 months. And what we found is that about half of the data came from about only 10% of the users. This user group, so I categorize users into different groups by how many reports they submit, and then the content of the length of characters they submit. And these 10 users, they tend to submit a lot of smell reports and also contribute to a lot of the content in the report. In total, we have about 3,900 users, about 17,000 smell reports in 2 years. I also did a text analysis, and what we found is that all the high-frequency words, they are related to industrial pollution odors, and also the symptoms are related to the exposure to air pollutions, such as hydrogen sulfide. So in here, I'm going to show you the frequency graphs. On the left one is called the unigram. That means I'm counting the frequency of words So you can see industrial is the first one. On the right side, I'm presenting the bigram, which means I'm counting the frequency of phrases of 2 words. In here, you can see wood smoke and rotten egg. Rotten egg is actually how hydrogen sulfide smells. And now we are looking at the symptoms. So all these symptoms, they are related to eye, nose, and throat irritations. And these are related to long-term exposure to air quality pollution. Now, the second study, we want to investigate if smell data is useful in identifying the pollution patterns. So we use all these reports to build a prediction model to predict poor smell events from the air quality data. And here's how we do it. We want to estimate a function. In this case, we use a random forest. And then this is the input. So the rows are records, hourly readings, such as the readings coming from 5 a.m. or 7 a.m. And these readings, they are from county monitoring stations. The columns, they indicate predictors, such as hydrogen sulfide, sulfur dioxide, wind direction, wind speed, wind turbulence. In here, I'm including the current hour's data plus all the data within the last 3 hours. The output is a binary vector, says yes or no. Yes means there is a smell event. So I'm summing all the smell reports for the next 8 hours. And if it's larger than 40, then I'm saying yes, there is a smell event. Otherwise, it's a no. One thing to notice is that this data set is highly imbalanced because there's only 8% of yes and 92% of no's, which is more challenging than a data set that is balanced. We only predict smell events during daytime because nighttime people don't really report. This is the distribution of smell reports over time. Usually, people report smell on like 8 or 9 a.m. And there are possible explanations for this. For example, people wake up in the morning and they go to work. So that's the time when they go out and they smell something, so they report. Another possible explanation that we get from the community is that the factories, they usually emit smoke during midnight. And then it takes some time to travel from the pollution source to Pittsburgh. And then when people wake up, open up their window, they smell that. So in the previous one, I talked about the prediction model. In that model, we can get about 0.7 F-score. But we not only want to do the prediction, we also want to understand the patterns in our data. So in this case, I'm manually selecting features from our data set by using community knowledge. For example, I go to community meetings, so I know hydrogen sulfide is a problem. And also from the text analysis, I also found rotten egg smell. So I manually select hydrogen sulfide, wind direction, wind speed, and wind turbulence. For the data, I use a cluster analysis to select only 2% of the similar samples. So in this way, I can train a decision tree model, which is easier to explain. And the details are in the paper. Here, I'm going to jump to the results. So I'm going to walk through to the tree. And this tree can explain about health of the smell events, which was a joint effect of wind direction and also hydrogen sulfide. Okay, I'm going to use my mouse cursor here. When we look at the first node of the decision tree, it's usually the most important one. So this is telling us that it's looking at a monitoring station here. This is our Parkway East monitoring station. It's looking at the wind direction in the north-south direction, multiplied by the hydrogen sulfide readings from the previous hour. So that means it's a combination of the wind direction and also the hydrogen sulfide readings. By just using this feature, we can reduce the number of negative samples from 16,000 down to 300. So that's a really important predictor. And then when we look at the second node, we can see that it's a pattern of a combination of wind. So it's looking at the wind directions from this monitoring stations to here. And just to give you an idea, the CMU, I think CMU is probably here, Carnegie Mellon. And then this is the area that affected by the pollutions probably the most right now. And when we keep looking at these nodes, they are all telling like the combination of wind multiplied by this station, and so on. So in this way, we can explain the patterns, like maybe the factory emits something, and then when the wind forms this pattern, that pollutant will travel to this area, and then people will smell something and report them. We also did a survey study of 25 participants, and we used a validated survey tool developed by the Cornell Lab of Ornithology. We measure the self-efficacy increase and also the motivations. Self-efficacy means if users are confident that they can achieve the goal or not. We found about 0.5 Likert scale increases after using the system. We also found internal motivations is larger than external motivations. Internal motivations means like enjoyment of participation. External motivation means fame or money rewards. Here are some open responses. Communities, they mentioned that now they feel more confident. They now feel they are contributing to taking data. Also, they mentioned that they don't have to make a phone call to the health department anymore because they can just use the app to report the complaint. About 24% of the participants mentioned altruism, which is the concern about the welfare of others. For example, they said that the Smell Pittsburgh data they can show them to new activists and talk to them that not just they care about the problem, but other people also care about the problem. That helps building momentum in the air quality community. About 16% of the participants mentioned that they can use the data, the system, to validate their personal experience. For example, now they can confirm what they are seeing, and they know that they are not alone because they can see the visualization and see that other people also has this problem. Here are some takeaway messages. So we believe that from our analysis, smell data is a viable source for identifying local air pollution patterns. And here are some numbers. In 2017, we collect about 8,700 reports compared to the data collected by the health department. They collected about 800 reports in 2016. This is about 10-fold increase in quantity. But we also have the increase in quality because their data has 45% of them missing location information. But because we are using the GPS location, so we don't have missing information. Also, we use machine learning to predict the poor smell events from air quality data, which shows that data is not just random noise, but something with patterns. Our system also empowers communities to use the data to communicate with regulators. So in this case, communities, they present their data on a health board meeting by printing out all the smell reports in a school. When they present this to the regulators, it actually influences their attitude because this is a concrete evidence. And the regulators, they now said that they will enact more strict rules on the coke plant factories in Pittsburgh. So in this way, the Smell Pittsburgh tool arms the citizens with the scientific evidence and also facilitates the communication between the government and citizens. So thank you for coming, and just some advertisement. I'm looking for a faculty position this year. So if you know any openings, I would be very grateful if you could let me know. Thanks. I'm happy to take questions.
Talked about the motivations, altruistic kind of motivations. Can you highlight what elements of the app were explicitly used for intrinsic or extrinsic motivations as well?
You mean like what's the part of the app that?
Yeah, like how are you, like what was happening with an app that was motivating them to participate more? That was not just altruistic, but just for them, like intrinsic or extrinsic. Like, were there external factors like some form of fame or I don't know, like something that was happening? Like what were the design decisions made around that?
Well, this actually goes to our previous project because this project does not just come from here. We have a previous project that we experimented this on a smaller community. And then when we developed that with them, we didn't mention any smell thing to them. But at that time, well, we were using the cameras to monitor the factory. But people mentioned a lot about like how these factories affect their life by using the smell. And we thought maybe we can visualize all this smell data together. I think the most important part for them is now they can see the data. Because before the existing of this application, they can submit reports and they keep calling the health department like several times. But it's really frustrating because the health department didn't like provide a really positive response. And then when they want to get the data, it takes a lot of time to go through the process, which is not really transparent. So they think the really powerful thing is now they can see this. And they can see like a lot of reports coming up together. And that they can take a screenshot to show this to other people and take it to like community meetings.
Hi, John Camp. I've been to Pittsburgh. I like your topic. Question for you here. Were you ever able to calibrate the crowdsourced representation of the smell with like a concentration of hydrogen sulfide or something like that?
You mean like correlations between these two type of data?
Yeah,
or?
so they'd said it smelled like rotten eggs, and they found out that when they took a measurement that the concentration of hydrogen sulfide was actually here, above or below some threshold.
Oh, yeah, we didn't test that, but that's a good point. Because I know there are like, maybe like other thresholds that above that threshold, people can smell it. Yeah, but we didn't test that. But thank you for the input.